Hi everyone, welcome to the walkthrough for Lab 6. In this lab, I'm just going to be going over the two questions of record produced and print triangle. Print triangle was pretty similar to what we did during class on Tuesday, on the 10th of May, where we just have these indents and asterisks printed out. This record produced one is a bit more complicated, and I want to take some more time to focus on it. So your record produce or rec prod is a recursive function that's going to take two non-negative integers. You could see the two non-negative integers are k and n. And what it will do is it's going to return the product of these numbers between k and n. So essentially, if I have 1 up to 4, it will be 1 times 2 times 3 times 4. And let's actually try to build this out programmatically before we even code anything. If I go ahead and do 2 and 4, oops, excuse me, let me put my numlock on. I could do 2 times 3 times 4, and that will go ahead and give me 24. And if I have 2 to 10, this is going to be inclusive of these numbers. So from 2 to 10, what it should do is 2 times 3 times 4 times 5. And we'll see here that I get 3628800. And if I look at my output right here, 3628800. So again, what it will do is just going to take two variables that are inclusive and then go ahead and print them out together for us, the multiplication. So this is going to be pretty similar to what we had for addition, except we're just going to do multiplication. And to go ahead and get started with that one, we want to make sure that we take a look at all the base cases. So for our first base case, and again, when you're doing this code, the base cases will be different in scenarios that you encounter. You can usually tell a base case if you have this keyword if. So if you ever see in your labs or assignments or midterm, or excuse me, final, where it says if, that's going to most likely be your base case. And the first one says here is if k is greater than n, then the product is defined to be 1. What that means essentially is that if some user puts in k over n, we're just going to return 1. And we can actually build it out with a simple if statement, like so. Now the second one here is if k is equal to n, then the product is defined to be k or equivalently n. So this could be a little confusing, but essentially if the user puts in two numbers that are identical to each other, we just return the number, because what's the multiplication between tree and tree? Well, it's just tree itself, right? So that's essentially what this one is telling us. And you know what, just to make sure that we keep it understandable, we can also write out return n as well. And either of these, return k or return n, will work for us, okay? So that's my first base case here. So my first base case is that if k is greater than n. My second base case will be if k is equal to n, that will return k. And then we could go ahead and we encounter this scenario where it's the recursive step. So we haven't really typed out recursive step before, but essentially what's happening here is how do I go ahead and get to my base case here? How do I eventually get to my k is greater than n? Because that's my main base case I want to look at, or my k is equal to n. What I'll need to do here is try to return the next step from, so again, if I'm doing 2 and 4, I need to try to get my code to do this here. So to go ahead and do that there, what we could try to do is return our record produced of k plus 1 and n, okay? So what's happening here is that this is my recursive step of trying to get to my base case, and let's actually see what we get when we type all this out. So if I do a is equal to rec produced 2 and 4, we'll see I'm only getting 4 here. So what's happening is that I'm eventually returning the value of k in this scenario. And what's happening is that k becomes from 2, it goes up to 3, it goes up to 4, and then it returns 1 once k is either, or excuse me, once it's 4, we return k. And so that's the k I'm getting back. So right here is where I'm getting this code to work. But you'll notice that I'm never actually multiplying my values together. So what I would need to do here is eventually do some recursive steps in order to get this output to return the full value. So instead of returning right away of recursive steps there, I could say something like my recursive number. And let me print out my recursive number here instead. you'll see here eventually I'm getting to none. So what I would like to do here is let me also try to print out k times my recursive number. So what I'm doing now is that all I'm doing is I'm putting the value of the recursive call into a variable, and I'm timesing that number times k. So this variable will always be changing in each recursive step, and so will this variable. Okay. And it looks like I'm eventually getting this return type that's not working for me because I have a none type that's occurring. Let me try to go ahead and just set this to a variable instead of printing it out right away. Try to print out A. And it looks like at the very end here, I'm getting 12. Still giving me a similar error because I'm getting a none type return for me because I'm never actually returning a value after A. So what I'll do instead of after my print A, I'm going to try to return A as well. So what I'm doing in this scenario now is I'm going up each step. K becomes 2, K becomes 3, K becomes 4, and I'm taking the recursive output and multiplying it on the way back. Okay. Now this is pretty much identical to what we did with addition, and you'll see here that when I get to the end down here, instead of returning a none type, I'm returning A, which eventually becomes the 24 instead of the none type. So you'll see here that if I don't have this return statement here, I get a none type error. But as soon as I do put in a return statement, I get the value put out for me. Okay. And to showcase what's going on in here in our code here, go into our Python tutor. And then we try to do record produce of 2 and 4. We'll see here what happens is that K becomes 2 and is 4 when it first starts out. I skip my 2 if statements and I go to my recursive step here. And now what happens is I call record produce. So what happens is I create a stack on my stack of plates essentially, and the stack contains a return value that isn't done yet. Again, the return value is going to be the multiplication of k times rec num. So this still needs to do k times rec num, and you'll notice that these guys are red because we're saving them for later essentially. If I click on these guys, this code still needs to run at some point. But the thing is that this record produce takes priority, so I have to jump up to record produce to rerun my code again. Let me go ahead and do this again. We could see here that we're always ending at line 10. And what happens is right here, right here when k becomes 4, k isn't greater than n, so then I jump down to my if statement, k is equal to n. And what do? I return k. So now this guy returns k, which is 4. And what is the return value from down here that gets put into play that this guy used to have to do? Well, we'll see here that k becomes 3 because this is the third iteration of a recursion, but our value of rec num now holds the value of 4. So this is essentially how we're passing values between each other. 4 was saved from the previous recursive call. Remember, we got 4 from the return value of our last base case. And now that we have 4 saved in our stack, we can give it back to the guy and say, you know what? You need this value to finish the 2 remaining lines of code that you had. And so now what happens is I get 4 times 3, which is 12. And what happens is that A becomes 12. A is the parameter I just used. It might actually be easier to just say return k times rec num so you don't have so many variables. But you'll notice here that I'm working with 4 different variables in my stack. So this is kind of how we're passing parameters around. And then I say, okay, go back into my other stack call, and what's the value of rec num? Well, it was 12 because I got that from the last one. Now, what's the value of k? It's 2. So k is 2 times 12, and then that gives me 24. So now that's how I do the multiplication, okay? If this one's a bit confusing, you could do it with addition. It's the exact same thing as addition, except we're using multiplication, okay? Python tutor is a nice way to visualize what's going on for this guy too. Now we'll see here for our print triangle, what this code's supposed to do is going to take 2 integers as parameters and prints a triangle of asterisks based on those integers. The first integer represents the maximum number of asterisks to be printed in the first row, and the second integer represents the indentation used for the first line of the pattern. So we'll see here that indentation essentially means how much white space is given to you at the very start, and the number of parameters or triangles is the first guy up here. So if I put in 6, I'll get 6 asterisks. We'll see here if I put in 7, I get 7, and so forth. So to actually go ahead and do this, basically, let me try to do a print statement here. And the way that I can actually print my indentation is by multiplying I by white space. We saw that on Tuesday. I take a bit of white space and I times it by I. And then I'm going to multiply my asterisks by the M value, which is going to be how much items are in there. Okay, so we can see here, if I just run print triangle on 6 and 5. Okay, it looks like I'm getting my first line of code looking okay. This looks pretty much identical to the first one. Now, what's my recursive step that I need to do? Well, it looks like I'm reducing the amount of asterisks. If I zoom in here, it's a bit rough looking, but we can see here that I have 6 up here. Then I have 1, 2, 3, 4, and then 1, 2. Let me look at 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 3 and 1. So now I'm getting a reduction of 2 in each iterative step, right? Or recursive step in this scenario. So what I would like to do is try to do a recursive call. Let me keep my I the same. So we'll see here, this is where it can get a bit confusing because your parameters, and this is an issue I see a lot in recursion, is that you don't want to mix up your parameters. The M parameter, even though we're calling them reversed in our code, this guy always needs to be maintained as M. So whatever I put in the first call of my function as a parameter will always be M. And what I'm trying to do is reduce it by 2 in each scenario. Okay? Let me do a print triangle of 6 and I believe it was 5. We'll see here that my code actually jumps down because I'm not hitting a base case. But we'll see here that I'm actually getting the 6, the 4, and the 2 properly outputted. But now I need to make a base case. Okay, so I want to make sure that I stop running at some point. And most likely my base case, you'll see here that after I hit 0, it looks like it ends. So what I'm going to try to do is if M is less than or equal to 0, I'm just going to do a basic return of a none type because nothing else will happen. Otherwise, I'm going to do my recursive step. Okay. Let me print my triangle of 6 and 5. We'll see here that my recursion stops and I go from 6 to 4 and 2. This isn't really what I want to do because I also want to indent out my code. And it looks like each time my indent is pushing it 1 over in my code, it's going 1 step to the right. So I most likely just need to increment I by 1 as well. Let me try to do this print triangle. Nice. And this should work for any type of triangle that you want to work with. Let's do 12 and 10. And we'll see here that it's doing this type of arrow down. Okay. Awesome. So this one is much more complicated than the second print statement, but if you're getting comfortable with print statements, that's great for the homework. Definitely take a look at record produce more often just to kind of understand how we're getting the value passed back to us. And you can also do the addition variation of this as well instead of multiplication. Thank you, everyone.